Okay, we're going to look at finding the equations of lines. And so we're going to start with, what if we're given a graph and we want to find the equation? So let's say we're looking at this. So looking here, we can see the y-intercept is at 0, -1. If you remember with the equation, this was one of the numbers in the equation, 0b. So what we need to do now is figure out the slope. In order to figure out the slope, we need a second point. So let's say I go to this point, and to get from my y-intercept to that point, I'm going to go up 3 units and 2 units to the right. So my slope is 3/2. Since my equation of my line is y equals mx plus b, y equals the slope times x plus the y-intercept value, I have enough information to write my equation. Y equals 3/2 x, and the b is -1, so -1. Let's say instead I was told some information. I was told a point and a slope. Well, there's 2 ways I can approach that problem. The first way is I can use the slope-intercept form. This is the way I want the answer to look, so I can start that way. So let's say I wanted to find the equation of the line that passes through 612 and has a slope of -2/3. So I say, well, I want it to look like y equals mx plus b. And they told me the slope, m, is -2/3. So I can plug that into my formula, and I have y equals -2/3 x plus b. I'm half done. I just need to figure out what b is. And that's where this point is going to come in. 612 tells me when x is 6, y is 12. So what I can do is I can substitute those values into my equation that I have so far, and the only letter I won't know is b, this b that I'm looking for. So I make the x 6, I make the y 12, and now I just need to solve for b. So -2/3 times 6 is -4. Add 4 to both sides, and I get b equals 16. And that is not the final answer. Remember, I'm looking for the equation, so be careful with this method, because we've been doing problems, and a lot of times you'll solve for a variable, and that'll be the solution to the problem, and you'll think you're done. And here, we need to actually plug that b into our equation and say our final answer is y equals -2/3 x plus 16. An alternative method is to use what we call the point-slope form, which is y minus y1 equals m times the quantity x minus x1, where the letter y and x are the letters y and x. But x1, y1 are the point we know, and m is just like normal, the slope. So you know a point and you know the slope, so you use the point-slope form. So this is an alternative way to do the problem. So let's say we wanted to find the equation of the line passing through 4, 1 that has a slope of 5. So what I'm going to do is I'm going to take this formula and I'm just going to plug in all the numbers I know. So I know m is 5, I know for my point, x1 is 4 and y1 is 1. And now I should be able to kind of, follow the steps I know. I will distribute. So 5 times x, 5 times 4, 5x minus 20. And then I want to get y by itself. I add 1 to both sides and get y equals 5x minus 19. And that is y equals mx plus b. So I'm done. So this is kind of nice, because once you get all your numbers in there, you should just kind of follow your instincts at this point. Distribute, combine like terms. But what's bad about this is here's another formula you have to know. Whereas doing it the first way, using the y equals mx plus b directly, that saves me from knowing this extra formula. So which way's better? The one you can get right the most often is the better one. Alright, so let's look at some special lines. So horizontal lines always have a slope of 0. And the equation of a horizontal line is always y equals a number. So let's say I had the problem. I wanted to find the equation of the line passing through -3, 8 and it has a slope of 0. So I go, well, slope of 0, that must mean it's a horizontal line. If it's a horizontal line, it must have an equation of y equals a number. And the only y value I know is 8 for this problem, so it must be y equals 8. Problem finished, all done. There's my equation. But let's say you knew it was something weird, but you couldn't remember it was y equals a number. So you go, well, I have a slope, I have a point, I'm just going to put it in my point-slope form. So I'll make the slope m0, I'll make x1 negative 3, I'll make y1 8, and I'll see what happens. So I plug those in. Minus negative 3 is the same as x plus 3. 0 times anything, though, is 0. So adding 8 to both sides, I get y equals the same answer. So if you don't remember for a horizontal line that it's y equals a number, you can still work it out and figure it out. Now let's compare that to vertical lines. Vertical lines have a slope of undefined in an equation of x equals some constant value number. So let's say I wanted to find the equation of the line passing through negative 3, 8, and this one has a slope of undefined. Well, say slope is undefined, that must mean it's a vertical line. If it's a vertical line, it has to be x equals a number. The only x value I know is x equals negative 3. Now let's say you got into a situation and you knew this was one of the special ones, but you can't remember if this is x equals negative 3 or y equals 8. You think, maybe I can work it out. The problem is you can't. There's no way to work this out because undefined is not a number. There's no math you can do here. You either know if there's the slope is undefined, it's x equals a number, or you don't. And there's not much you can do to fix that situation. So to kind of help you remember this, I want to compare these special lines to some normal lines. So let's say we had this line. So the formula for this would look like y equals mx plus b. And because this line is going up as I go to the right, I know the slope is positive, some positive number. Let's compare that to this line. So again, the equation for this is y equals mx plus b. And now the line is going down to the right, so I know the slope is a negative number. So it's a number, but it's a negative number. Now let's look at this line. This is a horizontal line. Horizontal lines are always y equals a number, and the slope is 0. 0 is a number, so the slope is a number. This is y equals. Notice all three of these start with y equals, y equals, y equals. The slope for each of these is a positive number, negative number, or 0. Those are all numbers. Also, another thing to think about is if you look at these pictures, a lot of times graphs might represent number lines. So as things happen over time, so in the upper left-hand corner you might think things are getting better or greater over time. In the upper right-hand corner things are going down over time. Whereas in the lower left-hand corner things are staying the same over time. So with that in mind, if we look at this graph and we think about time, well, this doesn't really make sense in that case. This is going straight up and down. That means at one time it's everywhere. It's all up and down, but it's only at that one moment that it's everywhere. It's not going left or right at all. This equation is x equals a number. Notice y equals, y equals, y equals, x equals. Well, that's different. And this slope is undefined. So all of these other three all look like kind of like a number line might look. They all start y equals, y equals, y equals. They all have a slope that is a number. It's a positive number, a negative number, or 0. But this lower corner one, the vertical lines, don't start the same. They're x equals, and their slope is not a number. It's undefined. And it doesn't make sense for a number line to look like that. So, this might make you think of something from, when you were a child. So, that's a little, from Sesame Street. Pick the one that doesn't belong. This one doesn't, the x equals c, the vertical lines don't belong with the rest. It's different. So if you think about all that different weird stuff all going together, hopefully that'll help you remember how this equation works. Because again, remember, you can't work these out. You just have to know it's x equals a number. All right, let's look at what if I'm giving 2 points? How do I handle that situation? So first thing you want to do is find the slope. So you're going to use your slope formula. And now that you know the slope, you can use either your slope-intercept form or your point-slope form to find the equation. And you can use either point. All you need is a slope and a point. So if you have 2 points and the slope that you've calculated, then you have more than enough information to find the equation. You just have to pick one of the points and use the slope and find the equation. And you, like I said, you can use y equals mx plus b, or you can use y minus y1 equals m times x minus x1, the slope-intercept form or the point-slope form. So instead of me just giving 2 points, let's look at what if we were using a graph to find the equation. So let's say I want to find the equation using this graph. And you notice my y-intercept doesn't cross at a whole number. So I can't just say, oh, I know what b is. I don't know what b is. It could be a third, it could be a fourth, it could be 2/7, I don't know. So what I'm going to do is I'm going to look around and I'm going to try to pick some points that are right on one of those grid lines. And I want to pick this point because it looks like it crosses at, you know, these 2 grid lines, and then I'm going to pick a point over here. These 2 look like they cross at grid lines. And so this first point, this is -3, 2, and this other point is 5, -4. And I'm going to use those points. So the first step is find the slope. And I'm going to call -3, 2 my first point, and 5, -4 my second point. You can do it the other way also. You'll get the same numbers. So if I plug that in, -4 for y2 minus 2, y1, 5 is x2 minus -3 is x1. So -6/8 or -3/4 is my slope. And then I'm going to use the -3, 2 point in the slope, and I'm just going to find the equation using the point-slope form. So plug those numbers in. I want to distribute the -3/4 x, and then -3/4 to, well, that's going to be a +3, so a -3/4 to a +3 is going to be a -9/4. Add 2. Remember, 2 is the same as 8/4. So combine, add those fractions together, and you get y equals -3/4 x minus 1/4. And let's see, does that make sense? Well, the slope's negative. It is going down. If I look at the y, where it's hitting the y-axis, it is in the negative area, and it's a small number, so -1/4 would make sense for where that hits. So this is probably the correct equation for this line. So that's how you do. If you have 2 points, find the slope, and then use one of the points in the slope to find the equation.